Hello everyone, welcome to the HCIP OpenELR certification course. Now let's continue to learn about the OpenELR storage management. In the previous section, we have introduced the principles of NFS and focus on the components of NFS utils and RPC bind. Now that we are familiar with the NFS workflow, let's learn how to perform the NFS experiment.
In this experiment, I have logged into the corresponding devices, namely client 1, 2, and NFS server. In this experiment, we will perform operations according to the experiment guide. And we have said that the NFS is the typical CS file system. Therefore, we need to install the server and then install the client to access NFS. So we need to operate on our server side first. And first, check whether NFS and RPC bind operations are performed in the environment according to the experiment guide. And the operation guide describes the commands in details. And we run rpm-aq NFS to query the corresponding software package and filter the software package contained in NFS. It is found that the software package does not contain, and then we query whether the software package contains the RPC bind. We find that the software package has the RPC bind because some component package have it already, some are not. And here because we have it, so we can use it directly. And then we don't have NFS, so now we have execute yum and install NFS. The installation speed is fast. After installation is complete, let's check whether the NFS package exists. After query, we can see the NFS package exists and RPC bind package exists. When we have these two software packages, we can use them. First, we need to check the status of them. Of course, you can start them and then query them. Okay, now we check the service. We can see that the service is not started. Therefore, let's start the service. In this example, the command line is to set the service to be started upon system startup. So enable to set the service to be started upon system startup. And then we set start the service. After entering the two command lines, we can query the status of the service again. At this time, we will find that the service has been started and it's enabled when system restart. And now I can configure a service for it. And here, please do not forget to configure the startup enable. Otherwise, once the service is shut down and restarted, the service needs to be manually enabled. And now, let's create a shared directory. As mentioned before, the shared directory needs to be enabled on the server side, which is a process of providing a file service. So here, we create a directory. And then we query it. In this, we can see that the data folder can be created. And next, we need to edit who has access to this folder. because here we just created it now, and we need this shared directory be accessed through the client. So therefore, we need to edit who can access the shared directory and who cannot. This is a key feature when we set file storage permission setting. So now let's edit it client information first. In this example, the configuration file is stored in exports of etc directory. So we switch to etc directory, and then we can see the ports. So here we can use multiple methods, for example, use echo or use vim to edit this file. And here, this is one of our filing content. We have a few key points to pay attention when we're using it. First of all, what is this RW? RW is a permission that we set. That is, we are read and write. Read and write. If you want to set a certain person to read only, and then you can just give it RO. But our first step is to set a permission that everyone can access. So it is written and read operations, W. And then the second thing is that all the file modifications will be written to the disk when the client is replied. And then the next thing is no root. If a root user has the permission to access the NFS root directory, the root user retains the permission. Otherwise, the root permission by default is not enabled. So after we edit it, we remain such a root permission. And then what does this start stand for? It represents the person you will access. You can write other content. For example, I can write a private IP address. It means only this IP address is allowed to access the client, and others cannot access the client. And here we set it to start, which means everyone can have a access permission. So this is a basic configuration of the shared directory, which is to create a shared directory and then set permissions. And if you are finished with the configuration, you can save and exit. And after the configuration is complete, we can look at one of our configuration process to see if there is any error. If the content is wrong, it may not be possible to use it. And then after check, we start the NFS because the configuration take effect only after its restart. And then we need to check whether the shared directory takes effect. So we run the command show mount-e to check whether the shared directory exists. At this time, we can see that the data directory already exists, and then the start indicates all users can access the shared storage. So it indicates that I have created the shared directory successfully, and the access permission is all. And now that the server has been configured, we need to configure the client. So what does the client need to be configured? First, the same, you need to install an NFS component on a client, such as RPC and the Ceres components. So let's look at the corresponding operations. First, we log into client 01 and reinstall the NFS installation package. So we run yum first. Now the installation is successful, and then the previous operations are the same. So you need to start the NFS service and then perform related operations. System control start NFS. After the startup, the NFS service has been started. So after startup, we need to access the NFS service. Before accessing the ECS, you need to check the network connectively. And here, let's see the IP address of this ECS NFS is the 192.168.1.6. So let's try to pin it and check whether it can be pinned. After the pin, we find that the NFS server can communicate with each other. As long as we have communicated, we can access the corresponding directory. And because here we have already created a mount point on the NFS server, so the data directory, now I'm going to the folder on the client 01, and then we need to display it. That is, I need such a directory to match it. Therefore, we need to create a directory. Also, it's called the data. And it's under the mount data directory. And then let's see, there is a data directory. And then we can see that there is already created. We can perform a mounting task. Before the mounting task, you need to check whether the mounting point exists. So we can use show mount -e command and with the IP address. At this time, we found the file with data was on it. And then next, I'm going to mount it to my local device. Use the mount command -t NFS. But notice that the mount type is NFS, which we used to talk about mounting part. You can add folders or disks. The NFS storage is a network storage device. Therefore, you need to add a type of the NFS storage device. So here, -t is a type, and then the type is NFS, and they entered its IP address 1.6, and the columns, the folder information. The address followed by mount -t is the NFS IP address with the file address, and then the folder to which the NFS is mounted. We mount the NFS to the data folder of /mount, and then it means the mounting is complete. So after checking, the mount is successfully, and then we continue to switch to the directory, and then we can create a file. For example, we can create a test.txt file, and then I'm going to write client 01 in this task. We use vim and then type client 01. And then let's see the content is client 01 now. And it's under the data directory. Alright, now we will go into the NFS server and see there is the information in our folder. And now let's look at the test.txt. Then we look at the content of the test, and then we can see the client 01. So you can see this we have created on client 01, but its appearance on the NFS, that is file system sharing data. So after the configuration of client 1 is complete, we can perform similar operations to configure client 02. And here you can see my demonstration because we have just described it. Okay, now I'm creating a new folder, and then we'll see how it mounts. After checking, we found out if we already had it, and then we're also going to this folder to see if this file is also here, and the content is also correct. So we mount first. Use df-h, they mount successfully, and we switch to the directory. We use cat to see the content. It's already here. So now the client 1 and client 2, including my NFS server, can be viewed. So now let's try to modify client 02. Now the file content is client 1, and I add client 2 to the end of it. At this time, you should note that I'm editing on the client 2 server. And after query, we have successfully added the file. And then let's go to the client 01 and check whether the content has changed. It means we have now client 1 and client 2 can edit my folder. and this is the file storage sharing. The above is basic service configuration. Through the service configuration, we can simply understand the CS structure, server installation, and client access process. Also, you need to practice more to achieve a better understanding of these principles. Next, let's introduce some other features of NFS, in which we need to modify the permission. So first of all, let's look at how to modify it. Just now, we have introduced the permission control. That is, we have just performed a permission control in export. So let's look at it again. The permission we just created, that is, everyone can read and write. And now we were going to modify it. Only client 1 can read and write, but client 2 can only read and not write. So now I need to edit it. So if I want to edit only one, I cannot use the stars. I need to use its IP address. So let's look at the IP address of client 1 is 1.75. So let's put it in. So 1.75. And now 1.75 can be used normally. Okay, let's save it now. At this time, let's look at the mounting status of client 2. The mounting status is still here, and then let's go to the file to see the information. The information is still here. So why it's still here? Because I told you that if you need to modify something, you need to restart the service. So after the service is restarted, let's look at again. When we enter the data folder again, we find that the file is gone and the mounting is gone. So what does this mean? This indicates that now only 1.75 can be accessed. So let's look at the client 1. The mounting status of client 1 is still here. So that is the control permission. And now we need to add client 2 to this file. So let's see the IP address of client 2. It is 1.143. And then here we set it to read only. So we just set it to RO. And then we fixed it and save. Now let's check our mounting status. It's not mounted yet, so we're going to mount it again and restart the service. By this time, we have successfully mounted. So notice that what is this tips? My access request is rejected. That is, I did not restart the NFS service. So as a result, I cannot mount the NFS service. And after restart, it is successful. So now let's check whether the test.txt is still in the data directory. We check the content, and now I modified the 01 file. Change the 02 to 01111 multiple 1, and then we can check that the content has changed to multiple 1. And now I'm going to try to check these things from client 2. It also has been changed, and then we're going to edit the page again. But it's based on the 02. And here it have a warning that it is a read-only file. Even if I write something in it, you will find that it's not allowed when I save and exit. This is because the read-only file permission can only be read but not be written. So that is the NFS permission control. And you can use this permission control to check the NFS. So now we are out. And if you want to create a new directory in this path, well, fact, it's not possible because its permissions are insufficient. So that is the permission control. And finally, there is another knowledge point to explain. That is our mounting. Once it is restarted, the mounting is gone. You need to mount again. That is very troublesome. So here we need to set automatic mounting upon startup. You need to edit the mounting file. The mounting file is under the etc directory, the fs tab. So let's edit the mount file. We use vim etc fs tab. The editing content of the mounting file is the path where you want to mount the path. Enter it. And here I'm mounting the NFS data path to the mount data directory, which is the mount point. And then note that the mounting mode is NFS is followed. And then set automatic startup mode. By default, the first 0 is the 0 of the backup file system. In most cases, the 0 is just 0 and does not need to be backup. And the second 0 indicates the consistency check of the file system. In this case, the consistency check is not performed. So that is 0. And then we save. Also, after setting are saved, we restart the system and check the mounting status. So now that the host has been restarted, and then let's check that its mounting status is still here. At this time, I also restart 01. But we did not edit 01 just now, so 01 is not set to boot mounting, and when we restarted it, now we found that the mounting status was gone. Therefore, do not set the automatic mounting. After the system restarts, the mounting status is cancelled. So that's all about our NFS experiment.
This section describes how to set up the basic environment until the test is complete. Then, we summarize the common command parameters during the experiment. We hope that you can use your spare time to practice more in the future, so that you can better understand the NFS experiment operations and related principles. In the next section, we will introduce another type of SAN storage among shared storage. Thank you for watching.